Mitsubishi have been working on a product for, I think it's 10 years in their labs in terms of putting this together with a bunch of very clever data scientists. And they've just released a product called MailLab. And it's the new data analysis software from Mitsubishi. What it does, it allows you to literally throw some historical data at it, tell it what you want to optimize. It goes off and runs, I think, up to 10 different types of models, because again, you have to choose the correct model type. Alvin, tell me if I'm wrong, to get the right results. There are many different ways of doing this. Whereas now with the software, you literally can build the models, it looks at all the data, it throws out the outliers, it does the model, it finds the best model to fit the data, and then you can use it and feedback into the PLC to do some control. I've got a video now and no programming. So you don't need to be a data scientist. Okay? You don't need to be, you don't need programmers anymore. Literally, you need CSVs. And one thing we are looking at is possibly next year is the ability to use a Droid as a data source. Right now, there's a manual process. You have to export the data, create the CSV. But can you imagine being able to link directly into our historical files and run the model directly from there and link it back? It's all possible. Christian Nomine is the European Strategic Product Manager for Visualization and Analytics, and I'm going to just run 2 videos. It's a lot easier. We have the software, and off we go.
Hello, my name is Christian Nomine, and I'm Strategic Product Manager for Visualization and Analytics at Mitsubishi Electric Europe BV. In the following minutes, I would like to quickly introduce our new data analysis software called MailLab to you. And it's all about data. I'm sure you are collecting a lot of data already in various systems, data loggers, PLCs, SQL databases, SCADA systems. But the problem with data is it really needs to have an additional value that you can find in this data. And AI as a tool to bring you additional benefit can exist in various levels. And the reason is clear, it's depending on your demands about response time, server network costs, or even cybersecurity. But even more important is to define your real and clear goal and your kind of headache that you need to solve with additional data analytics. So typically, this could be an increase of quality, energy optimization, process optimization, or predictive maintenance. And MailLab is a tool developed especially for the automation engineers, for people who are not experts in data analytics yet. So we make the first entry steps into the big world of data analytics and AI much, much more simple. So the concept is basically, after you have set your goals, you need to come up with a reasonable data set to be able to find out what process parameters or what environmental parameters could be beneficial for you to bring into a data analytics software, to learn specific models from that data. And once you have confirmed a good precision for this, you will take that model one step further from offline analysis into online analysis by continuously reading in data from your process, comparing it against the model, and giving the feedback, the prediction of the model back into the PLC or OT level. So MailLab especially helps you in giving you one solution which covers all phases of a data analytic project. So the very important first part of pre-processing of the data, from selecting the analysis method, and then finally learning the model and putting this into an online analytic mode. All these steps, MailLab will help you and guide you through these steps because we have our own virtual AI data scientist built into this tool. Set a goal, read the data with a data set, create an analysis model, and create a continuous analysis. These are the 5 major steps where we help you and we guide you, and we actually give you a tool where you don't need a data analyst to get additional value from the data. You can do it yourself. And you will have a quick win from this tool for sure. So just talking about very quickly 2 typical use cases. Predictive maintenance is for sure one of the most important ones to cut down operational cost. So what about if you have a piece of equipment which requires continuous and periodic maintenance, but you are not sure whether this maintenance is really required like every 6 months. So you could create a data set consisting of process parameters, maybe some environmental parameters like ambient temperature, outside temperature, just to give some examples. And you could learn a model which is able, based on data, to predict between normal and abnormal data. And the result will be to optimize the number of exchanges of a work tool, for example, and we can achieve a cost reduction. A second example, just imagine you have some kind of equipment, and this is like, for example, a noodle making factory. So we have a very experienced worker on this line, and based on manufacturing information, but also based on environmental information, he knows from a gut feeling how to set the perfect control parameters, for example, for the noodle kneading time, in order to make the best noodle quality in terms of elasticity. So with MailLab, we could learn from the experienced worker. We could transfer his knowledge based on some historical data that we feed in as a data set to MailLab, and we can create a kind of guidance system to an unexperienced user where MailLab is proposing some set points to him. He is still in the game. He still has the last decision that he needs to do. But we guide this young man based on the experience of the older worker and experienced worker, and we give him a tool to set the perfect control parameters and the perfect noodle kneading time. And with that mechanism, we can eliminate the shortage of human resources. We can pass on know-how and finally also guarantee a more stable production with highest quality.
I would like to give you a live demonstration of a typical example that we can solve with our data analytics software called MailSoft MailLab. MailLab is a web-based software, so once we started it, MailLab will guide you with an intelligent AI-driven configurator through all the steps required for the project. So that is, we need to create a data set, first of all. We need to create an AI based on that data set. And finally, we need to create a task, which is an online analytic way, which is very much similar to your understanding of a task running in a PLC, for example. So when we start with that, and the first step is creating a data set, we need to make sure that we covered all required process parameters and ambient parameters from the process, which are crucial according to the process experts to give value into a data analytic model. And in this example for the noodle factory, we have a demo data set consisting of 7,000 records. And that data set can obviously be viewed in a table. And one of the most important things is that the last column, the noodle kneading time, is what we have logged and recorded over time from an experienced operator, how based on these process parameters for the noodle making process, he did set the perfect noodle kneading time. So you can look at this data. MailLab is offering some great graphical tools for that. So first of all, you see a lot of statistical data, but we can drill deeper. We can select the noodle kneading time and just create a line chart, for example. And we will understand that these 7,000 data sets are consisting of little variations in the noodle kneading time between 12 and 16 minutes. So we have confirmed our data set. It's good, it's valid, and we can actually do the next step. And once completed, MailLab will propose to create an AI. So MailLab offers 4 completely machine learning based automatic algorithms. But for those who already have an experience in data science and they know what to do with all these algorithms, supervised learning algorithms, unsupervised learning algorithms, they can completely start a manual project. But this is not us. This is not us for this demo. What we would like to do is to create a completely guided system based on our noodle kneading data set. And MailLab will propose the 4 typical use cases now that are implemented almost completely automatic. So there is to detect errors. For example, this is a typical predictive maintenance task, wearing out of parts, for example. There is a quality index for supervising the machine when it produces a part. What is the quality of this based on data? But what we would like to do is the third point. We would like to learn from skilled operators and to transfer his knowledge into an AI. And in this little example, and you will see this in the next step, the knowledge inside the data set sits in his chosen set points for the noodle kneading time. And this is what we would like to predict with that algorithm. So we will select this noodle kneading time. And then the AI is actually almost ready to go. All we need to set is the different level of complexity of the model that we would like to learn. We would like to start with the easiest one, which will result in the highest speed for this demo, as well as selecting only 2 algorithms. Also MailLab, from the toolbox that it has with many different algorithms, it will pick the ones which are best suited for that specific application. So once we start the learning, you will see that the whole pre-processing will now start automatically, and actually it's already done. We will optimize the model, and we will finally once this is done, and you see it's completed in 10 seconds, we will be presented with a so-called precision score. So this is a percentage between 0 and 100, which indicates the precision of the algorithm. So MailLab is also clearly saying to the unexperienced user that this is a good score, but even more helpful, from all the process parameters that we collected in the dataset, MailLab shows a graph which of those process parameters has contributed to finding this precision and this model most. So in that case, it's flour. When we are happy with that model, MailLab will present a kind of block diagram where you see in pink all the pre-processing blocks that MailLab ML has put together, the two parallel algorithms that MailLab has tested, and something which is called an ensemble learning block. So we are actually adding another layer of AI by trying to analyze each individual model and trying to make it even better, and only the best result will then be the output and the prediction of our AI. So you will get a feedback here, for example, with a score. Yeah, and of course, this is just a demo and very quick, but you would now typically go back to the process engineer and ask him, well, if we run this model, is it good enough with a precision of 90 or, for example, 93% to make it worth? Is it worth actually running it online and creating a task? In this quick example, it definitely is. So we created a task, and you see that the task is something I can stop and start, just like a PLC. And a task can also be configured. And the way it can be configured is we are now creating the closed loop flow of information from an input flow. And you see, for example, there is a variety of streams available. So it could be text files, simple CSV files that you, for example, export from your SCADA system. It could be a direct Mitsubishi driver that I'm using right now, an OPC-UA server connection, or even a database connection. Those are the typical types. So we are defining our physical channel for the live data. We are then feeding this live data into our AI, and we will calculate an output with a prediction of that model, and in that case, the predicted noodle kneading time. So again, when we run this, MailLab also comes with a built-in, very nice and advanced looking graphical engine, because once it's running, just give me a second here, we are then able to go into the monitoring mode, where another tab will be opened. And now what you can see is that each second we will retrieve data from the incoming process. This is a kind of diagnostic page here. You will see that calculating the model will take this amount of time, and writing the output back to the PLC in that case will take that amount of time. But most important is, of course, the prediction. You see all the process parameters coming in here continuously, and MailLab is now based on the process parameters, the perfectly predicted noodle kneading time with a dedicated precision that the model allows you. In that case, it's 90 or 93%. Thank you very much.
What do you think? Interesting, eh? lots of potential, and it's about trying to find those guys who can actually use this as part of the process.